Hi, welcome to Algebra 2 Common Core. Today we're going to practice evaluating exponential expressions using the rules of exponents that we've talked about in the last two lessons. In exercise number 1, we want to write each expression in exponential form as b to the m over n. So if we are multiplying b to the 2/3 times b to the 1/2, since the bases match, we keep the base of b and we want to add those exponents together. So we'll say b to the 2/3 plus b to the 1/2. Now, of course, we need to add those exponents by finding a common denominator. The common denominator will be 6, so 2/3 is the same as 4/6, plus 1/2 is the same as 3/6. So as an exponential, this would be b to the 7/6. Now again, notice that we want to leave our answer in the form of an exponential, not rewrite it as a root. For part B, we're raising a power to a power, so that means we're going to multiply our exponents together. So b to the negative 1/5 times 2/3. Now when I multiply, I do not need to have a common denominator. So multiplying negative 1/5 times 2/3 is giving me b to the negative 2 over 15. Now again, since the instructions said to leave it in the form of b to the m over n, I'm going to leave my answer in that form. Another equivalent form that I could write it would be 1 over b to the positive 2/15. So whenever I have a negative exponent, I move the base to the denominator or take its reciprocal, and then the exponent would be positive. For part C, when I'm multiplying, just like in part A, I want to keep the base the same, even when I have a number as the base. So my base is 64. I want to add the exponents together, so 1/3 plus 3/2. Again, to add those exponents together, I'm going to have to find a common denominator. So this is going to be 64 to the 2/6 plus 9/6, which gives me a final answer of 64 to the 11/6. And again, this did not say to evaluate, so I don't need to write it in root form or give the final answer. In exercise number 2, we again want to use our exponent rules to simplify and make sure that we write all of our answers with positive exponents. So 4 to the negative 3rd times 4 to the negative 1. I'm multiplying and the bases stay the same, so I keep that 4. I don't multiply 4 times 4 together. I keep the base of 4. I add the exponents together, so it becomes 4 to the negative 4th power. That, of course, with a negative exponent would be rewritten as 1 over 4 to the positive 4th power. And this one I can keep going because it does say to simplify my answer. So 1 over 4 to the 4th is the same as 1 over 256. Now in part B, I have a negative exponent. So one way to simplify this is to take the reciprocal of the base, and by taking the reciprocal of the base, I'm going to make that exponent positive. So I'm going to rewrite this instead of 1,000 over 27, this would be 27 over 1,000. And by doing the reciprocal of the base, I can then change my exponent to positive 2/3. Now, because I know how to do this as a root, I'm going to say let's take the cube root of 27 over 1,000. And then the power is 2, so I'll raise it to the 2nd power. The cube root of 27 is 3. The cube root of 1,000 is 10. But then that answer gets squared, so my final answer is 9/100ths. For part C, I'm dividing. Again, the bases of the exponential match, so I keep that like base 100. When I subtract those exponents, it becomes 1/2 minus the exponent in the denominator is -1/2. So be careful there. We want to say 1/2 minus -1/2. Now, when we subtract 1/2 minus -1/2, that becomes 1/2 plus 1/2, which is 100 to the first power, which of course we all know is just 100. For part D, I of course have to do the operations within the parentheses first. So I'm going to have 2 to the third power, which is 8, 2 to the 0 power, which is 1, and I'm going to raise the whole answer to the 3/2 power. Again, I'm going to rewrite that as 9 to the 3/2 because I want to evaluate inside parentheses first. And I can evaluate this by saying this is the square root of 9 to the third power. The square root of 9 is 3. 3 to the third power gives me 27 for my final answer. For part E, I want to do the same thing and do those exponents first. So 7 to the 0 power, remember from the first lesson in this unit, anything to the 0 power gives me 1. 7 to the -1 would be 1/7, but I'm adding these together, so I'm going to find a common denominator. 7/7 plus 1/7 gives me a final answer of 8/7. For part F, this time the expression has a negative exponent in the denominator. So to make its exponent positive, I'm going to move the 3 to the numerator and give it that positive exponent of 2. I'm still adding on 1/3. So 3 to the second is 9. 9 plus 1/3. If I add those together, it's giving me 28/3. So look all of those examples over and make sure you understand how the exponent rules work to help us simplify them. Let's take a look at exercise number 3. We want to simplify, and in a lot of cases in these examples we've got variables, and some of them have coefficients that are numbers. So in exercise 3A, I see that my numerator has a term raised to the third power. So I'm going to raise each part of that to the third power, even the coefficient. So 4 will be raised to the third. X squared will be raised to the third, and remember when we raise a power to a power we multiply the exponents. Y to the first is raised to the third, so that gives me y to the third. In the denominator I still have 2x to the -1, y to the second. I'm going to take care of those coefficients first so that I can simplify the numbers. So 4 to the third gives me 64. X to the sixth, y to the third, divided by 2, x to the -1, y to the second. Now dividing 64 divided by 2 gives me 32. When I divide the variables, x to the sixth divided by x to the -1 would be x to the 6 minus -1. 6 minus -1 is 7. Y to the third divided by y to the second, again subtracting exponents, I get y to the first. So notice that this answer does have only positive exponents, so I can leave it like that, 32x to the 7th y. For part B, we have something similar in the numerator where I need to raise each factor in that term to the third power. So 3 will be raised to the third power. A to the -2 will be raised to the third, so multiply the exponents and get a to the -6. And b to the third will be raised to the third, so again I'm multiplying the exponents to get b to the 9th. We're going to divide by 9, a to the third, b to the -1. Now simplify the coefficients, so 3 to the third, remember, is 27, a to the -6th, b to the 9th, over 9, a to the third, b to the -1. I'm going to deal with the coefficients first, so I have 27 divided by 9 giving me a 3. Now we have two alternatives in ways to look at the division for the a's and the b's. I can either say a to the negative 6th divided by a to the 3rd and subtract the exponent in the numerator by the exponent in the denominator. So that would give me a to the negative 3rd power. Oops, I'm sorry, I made a mistake there. That should be a to the negative 6 minus 3, which is negative 9. For b, I'm going to subtract 9 minus negative 1, and that gives me b to the 10th. So rewriting this with a positive exponent, that would be 3, and b to the 10th would stay in the numerator, but the a to the 9th would go to the denominator. So there's one way of evaluating when I have negative exponents. Another alternative, and I'm going to write it in black ink here, another alternative would be for us to write my 3 when I divide the 27 by 9, but then make a fraction bar, and any variable that has a negative exponent we would need to take the reciprocal of. Any variable with a positive exponent stays where it is. So a to the negative 6th I would move to the denominator to give it a positive exponent. b to the 9th would stay in the numerator because its exponent is already positive. A to the 3rd in the denominator would stay there because its exponent is positive. B to the negative 1 in the denominator would move to the numerator, and its exponent would then be positive. Combining the like terms, I'm going to say 3 b to the 9th times b to the 1st is b to the 10th. A to the 6th times a to the 3rd gives me an a to the 9th in the denominator. So you can see that we get an equivalent answer, but I approached the first part, or the first example, the first way that I did it, I used my rules for division by subtracting the exponents. In the black example that I've drawn last, I've taken care of the negative exponents by making them positive and moving them to the numerator or denominator depending on whether they were positive or negative to begin with. So you see that there are a variety of ways in which to look at especially negative exponents and division. So you pick whichever way makes most sense to you and whichever way you are getting correct answers. In part C, we're going to raise each of the inside exponents to the outer exponent of negative 2. So x to the negative 4th, y to the 2nd, z to the negative 2. In the denominator, 2 to the negative 3rd, x to the negative 3rd, z to the negative 12th. Now, as you can see on the previous example, sometimes it's easy to make mistakes when you're dividing and the exponents are negative. So in this example, I'm going to use the second option that we just showed on the last example, and any exponents that are positive will stay where they are. Any exponents that are negative will move to the opposite location. So for example, x to the negative 4th in the numerator would move to x to the positive 4th in the denominator. That's just like taking the reciprocal of x. Y squared already has a positive exponent, so I'm going to leave it where it is. Z to the negative 2 in the numerator would move to z squared in the denominator. 2 to the negative 3rd in the denominator would move to the numerator with a positive exponent. X to the negative 3rd in the denominator would move to the numerator so that its exponent could be made positive. And lastly, z to the minus 12 would be moved from the denominator to the numerator so that its exponent could be made positive. Now we go ahead and do any simplification that we can. 2 to the 3rd gives me an 8. There's only one y term, and it's in the numerator with a positive exponent, so I'm going to leave it. I'm going to jump ahead to the z's. Z to the 12th divided by z squared. I'm going to subtract numerator exponent minus denominator exponent, so that's giving me z to the 10th. Now the x's are a little bit different. You'll notice that x to the 3rd is in the numerator and x to the 4th is in the denominator. So it would make it a lot easier if we just canceled off 3 factors of x in the numerator with 3 factors of x in the denominator. That would leave me 1 extra factor of x in the denominator. So my final answer would look like this. You can experiment with doing other operations by dividing and perhaps subtracting exponents and see if you get the same answer. Let's go ahead to exercise 4 where we see some function notation. We want to find f of 9 when f of x is equal to x to the minus 1/2 plus x to the negative 1. So substituting 9 for x, I really just want to evaluate 9 to the negative 1/2 plus 9 to the negative 1. So 9 to the negative 1/2 just means 1 over 9 to the 1/2, but that would be the square root of 9. 9 to the negative 1 would be 1/9. So this is really just the sum 1/3 plus 1/9. Finding a common denominator, that's going to be 3/9 plus 1/9, giving me a final answer of 4/9. For number 5, 4 to the 0 is 1. 8 to the 2/3 means the cube root of 8 squared. Minus 9 to the 1/2 means the square root of 9. So you'll see throughout this whole chapter it's going to be really important that you learn how to deal with fractional exponents, negative exponents, and all of the rules that we've been using for exponents. So adding together my terms here, 1 plus the cube root of 8 is 2, 2 squared is 4, minus the square root of 9 is 3, so 1 plus 4 minus 3 gives me my final answer of 2. For number 6, again we have function notation. So f of 16 is what we want to find. Here's our expression for f of x. So let's replace the x with a 16. So I've now got 16 to the negative 3/2. I, of course, want to evaluate this, so I'm going to say negative exponent means take the reciprocal of the base. So 1 over 16 to the 3/2 power. So that's giving me 1 over the square root of 16, and that's, of course, because I've got a 2 in the denominator of my exponent. But then I'm going to raise that answer to the 3rd power. So the square root of 16 is 4. 4 to the 3rd is 64. So I get 1 over 64. The input was 16. The output, 1 over 64. Let's go ahead and take a look at the last 3. So I want to find f of 9. Replacing x with 9, I have 9 to the 0 plus 9 to the 1/2. And you'll notice that this is all raised to the negative 2 power. Again, always when I've got a sum inside of a parentheses, I have to evaluate the inside before I raise to a power. So don't get this confused with our power rule where I raise each exponent on the inside to the outside. That only happens if I've got a product on the inside. When I have a sum, I've got to simplify the sum first. So 9 to the 0 is 1. 9 to the 1/2 just means the square root of 9, which is 3. So I have 1 plus 3 to the negative 2. That, of course, is 4 to the negative 2. A negative exponent tells me take the reciprocal of the base and raise it to the positive exponent. So that's going to be a 1 over 16. As I go through these examples, it might be a good idea to look ahead and see if you can solve them, and then come back and see if your answer matches what we have in the video. For exercise 8, x is -9, so I'm going to replace the x with -9. We'll add on 1 and then raise to the -2/3 power. So inside of the parentheses, I'm getting -8 to the -2/3. Again, I see a negative exponent. Now, don't get this confused with the base being negative. When the exponent is negative, I want to take the reciprocal, so I want to put -8 underneath 1. I'm even going to enclose it in parentheses there and make my exponent positive 2/3. So this means 1 over the cube root of -8 to the second power. So the cube root of -8 would be -2, and then I want to raise that to the second power, so that's giving me a final answer of 1/4. And lastly, we want to find the function value at 4. So substituting 4 for x, watch your order of operations here. So 3 times 4 squared plus 3 times 4 to the 1/2 plus 3 times 4. Now in each case, I need to evaluate the exponent before multiplication. Again, thinking about order of operations. So that tells me that I've got 3 multiplied by 4 squared, which is 16. Plus I've got 3 multiplied by 4 to the 1/2, which just means the square root of 4, that's 2. Plus 3 multiplied by 4. I'm going to go ahead and do all of my multiplication in the same step. So f of 4 would be equal to 3 times 16, which is 48, plus 3 times 2, which is 6, plus 3 times 4, which is 12. So when the input is 4, the output turns out to be 66. Take a look at these examples again and make sure you understand how we went from step to step. In class, we're going to be practicing a lot more examples with negative exponents, fractional exponents, and the operations with exponentials. Have a great night, and we'll see you in class.